Picture this: the universe as we know it, its stars, planets, galaxies, and everything in between, is only 5% of what's actually out there. Let that sink in. The other 95%? It's a mysterious cocktail of dark energy and dark matter, forces that we don't fully understand. And while dark energy drives the expansion of the universe, dark matter holds it all together. It's the invisible glue that keeps galaxies from flying apart, the silent architect shaping the cosmos itself. But here's the question that has baffled scientists for decades: what is dark matter really made of? Today, we'll delve into 5 mind-bending mysteries that might bring us closer to an answer. From the possibility of undiscovered particles to theories about higher dimensions and even echoes of a pre-Big Bang universe, this is a journey into the unknown. Let's start with the basics. Dark matter was first theorized in the 1930s by Swiss astronomer Fritz Zwicky. He noticed something odd: galaxies and clusters were moving so fast that, by all logic, they should be flung apart. But they weren't. There had to be something holding them together, something with mass, but invisible to telescopes. Fast forward to today, and we know that dark matter doesn't just hold galaxies together. It also shapes them. Every galaxy sits within a massive halo of dark matter, which provides the gravitational pull needed to form stars and planets. Without it, our universe would look completely different. But here's where things get really weird: dark matter doesn't interact with light or electromagnetic forces. That's why we can't see it. It's like trying to study a ghost using a flashlight; it just slips through our grasp. So, what is it? Our first big mystery: could dark matter be made of particles we haven't discovered yet? Physicists have long speculated that dark matter could consist of WIMPs, weakly interacting massive particles. These hypothetical particles would have mass, which explains their gravitational effects, but they wouldn't interact with regular matter in the way we're used to. Imagine trying to catch a breeze in a jar: it's there, but you can't hold it. To detect WIMPs, scientists have built enormous underground detectors shielded from cosmic radiation. The hope is that, just once, a dark matter particle might bump into a regular atom and leave a trace. But so far, nothing. Then there's another contender: axions. These are tiny, ghost-like particles that might behave more like waves than particles. Axions are so lightweight and elusive that detecting them would require instruments sensitive enough to measure ripples in space-time itself. Scientists are building experiments to search for axions, but they remain a cosmic enigma for now. Here's the thing: we know dark matter is there. We can see its effects on galaxies, on clusters of stars, even on the large-scale structure of the universe. But despite decades of effort, we haven't been able to detect it directly. One possibility is that dark matter particles interact with regular matter so weakly that our detectors aren't sensitive enough. Another possibility? We're looking in the wrong place. Some scientists think dark matter might annihilate itself when 2 particles collide, producing detectable gamma rays. Others suggest it might emit faint neutrinos, the ghost-like particles that pass through your body by the trillions every second. But so far, every search for these signals has come up empty-handed. Could dark matter be hiding in plain sight, using mechanisms we've never imagined? Or is it something so alien to our understanding of physics that we don't even know how to ask the right questions? Let's zoom out and look at the bigger picture. Dark matter doesn't just exist within galaxies, it also forms the cosmic web, the vast network of filaments that connect galaxies across the universe. But here's the mystery: why does dark matter cluster the way it does? How does it create the scaffolding for the visible universe? Scientists use supercomputers to simulate how dark matter behaves on a cosmic scale. These simulations suggest that dark matter might not be completely inert; it could have its own interactions, forming patterns and structures we don't yet understand. Some researchers even wonder if dark matter could influence the formation of black holes or the distribution of dark energy. In a way, dark matter isn't just the foundation of the universe, it might also hold the blueprints for its evolution. Now, let's go deeper into the rabbit hole. What if dark matter isn't just a particle or a force? What if it's a glimpse into a higher dimension, Some theories suggest that dark matter could be the shadow of particles from a fourth or fifth dimension, projected into our three-dimensional world. Think of it like the shadow of your hand on a wall. It's real, but it's not the whole picture. If this is true, studying dark matter could give us a peek into these hidden dimensions, rewriting the laws of physics as we know them. Finally, the most mind-bending mystery of all: what if dark matter is older than the universe itself? Some physicists believe dark matter could be a relic from a time before the Big Bang, a remnant of a previous universe that collapsed and gave birth to ours. If true, dark matter could carry clues about what existed before time as we understand it. Other theories propose that dark matter could be connected to black holes or even new forms of energy that existed in the universe's infancy. It's like trying to decipher the first chapter of a book when most of the pages are missing, but the answers could redefine our understanding of reality. Now, let's take a moment to talk about a cosmic mystery that's been making waves in the scientific community: the Hubble tension. The Hubble tension is a growing disagreement between two methods of measuring the universe's expansion rate. On one hand, we measure it by observing nearby stars and galaxies. On the other, we infer it from the cosmic microwave background, essentially the universe's baby picture. But the numbers don't add up. It's like trying to assemble a puzzle with pieces that refuse to fit together. Here's where dark matter enters the picture. Some scientists wonder if dark matter might play a hidden role in the Hubble tension. Could it interact with dark energy, the mysterious force driving the universe's expansion, in ways we don't yet understand? Could subtle variations in the distribution or behavior of dark matter be throwing off our measurements? And here's an even wilder thought: what if dark matter changes over time? If dark matter evolves or decays on cosmic timescales, it might create ripple effects that influence the expansion rate of the universe. We don't know for sure, but it raises an intriguing question: could solving the mystery of dark matter also unravel the Hubble tension? Or are these two puzzles pieces of an even larger cosmic mystery? Just think about it: dark matter might not only shape galaxies but could also hold the key to understanding the very fabric of the universe. The more we learn, the more questions arise. And that's the beauty of science, isn't it? Every answer is just the beginning of a new mystery. Despite all these mysteries, one thing is clear: the search for dark matter is one of the most exciting frontiers in science. Every experiment, every observation brings us one step closer to unraveling its secrets. And while we haven't found definitive answers yet, the questions themselves inspire us to think bigger, to dream bolder. Dark matter reminds us of how much we still don't know about the universe. It's a puzzle that challenges everything we think we understand about reality. So, what do you think dark matter is? Particles? Higher dimensions? Something we haven't even imagined yet? Let us know in the comments. We'd love to hear your theories. And if you enjoyed this journey into the unknown, don't forget to like, subscribe, and share this video with fellow cosmic explorers. The universe is vast, mysterious, and endlessly fascinating. Let's keep exploring it together. Stay curious, and stay cosmic.